working with speed equals distance over time, or any equation for that matter, using algebra skills. Welcome to Mr. Lawrence YouTube channel. Like and subscribe, as they always say. Anyways, so algebra skills. I'm gonna show the importance of using algebra skills for solving equations rather than memorizing tricks, and I'll point out some of those tricks, not really talk about them too much, but I will point out their shortcomings and why this is the way to do it for success going forward. So with algebra skills, main thing to know is that you need to do the same thing to both sides of an equation always. And if you do, then it remains the same, it remains true, right? So think of something like 2x equals 6. What that is meaning is that you have 2x on one side, here represented by these x rectangles. So this represents 2 of those x's. There's one there and one there, right? And then there's 6 ones, which adds up to 6. So you've got this balance, and this teeter-totter visualization really shows what the equal sign means, right? That they're balanced and the same on both sides. And so if we did the same thing to both sides, we could add 1 to both sides if we wanted to. There's no purpose in doing that right now, but it would still be true. It would just be 1 bit heavier on both sides, so it would still be balanced, right? That's one thing to know that you can always do. And the other main thing is to recognize that we want to undo everything around the variable that you're looking for, in this case x. We want to get x all by itself, right? And so if we can get rid of that 2, then we'll have just what x is, and on the other side it'll be the answer that x is equal to. So the process you do is you undo operations by doing the opposite. And so addition and subtraction undo each other, and multiplication and division undo each other. Right, so using those skills, we can do this, where we'd say, okay, well, we want to get rid of that 2. The key step is to ask yourself, okay, what's that 2 doing? And then we'll undo it, right? So the 2 is, of course, a multiplication onto that x. And so we would divide to get rid of it, right? So if we divide both sides by 2, we'll end up with the answer that x equals 3. So x equals 3, right? If you visualize this in the teeter-totter version, physical version of this, you divide this thing into 2 equal groups, and you have 2 equal groups that both say that x equals 3. Okay, so those are the kinds of algebra skills. With speed equals distance over time, I'm going to show you the 3 versions of working with that equation, and then I'll extend it to a trickier equation as well, and show that you just have to extend some of your algebra skills. So, for example, squaring, right? Squaring and undoing is square rooted, right? Would be one of the other main ones to watch for. Anyways, here we go. I'll also go through the idea of the grasp process of going through questions, tackling problem-solving techniques and so on. So as you're given, you're required, what they're asking for, analyzing the situation, substituting numbers in, solving, and then paraphrase, describing what your answer is. So I recommend, as you're reading a question, that you identify the things that you're given, right? So right away, we're given the distance of 40, and we're given the time of 28 seconds. And they're also asked for determine the speed of an animal, or the how there. Determine the speed of an animal that can travel 40 meters in 28 seconds. So we're looking for speed. Okay? So if we write that given and required information down, I'm kind of lazy, I just write given, don't do the required and whatnot, but it's implied in the process, and I'll show you. But yeah, you're given the distance is the 40 meters, and you're given the time of 28, and you're given, essentially you're asked for, but you're kind of given this required information, you think of it, right? So speed equals question mark. Okay, once you have that all set up, then for me, the analyze is looking at this, right? And really, I'm really encouraging you here to say, what do we have as an equation or a relationship that relates these concepts, right? And that, of course, is that speed equals distance over time. Okay, speed equals distance over time is the key concept, equation, relationship that relates these things. So at this point, you want to put numbers in where they belong, right? So you've got d equals 40, so that's going to go in for d. and we've got 28 for the t. That's going to go for t. And just make sure to put them in the appropriate spots in each case. It's not always going to be the top and the bottom on the right side. Okay, so watch for that. Once you have your speed, and you have your 40, and you have your 28, and so you do the calculation, go to the calculator here, and so we have the 40 divided by the 28, giving us the number of 1.428571, and so on. Obviously, you can't trust all of those numbers. This 40 meters was measured only to 40, give or take, half a meter or something like that, or maybe centimeters or whatever. So you might know 40.0 or even 40.00, but you certainly don't know all of those decimal places. So general rule of thumb is to just keep a couple decimal places round reasonably. And later on, you'll learn about significant digits where you kind of keep the same numbers that you started with. So technically, we need two numbers shown here. But if we added decimal zero and decimal zero, you can think of it as 3 and so on. But anyways, long story short here, 1.4285, you might round to like 1.4 or 1.43. Okay, so I'm going to go 1.43. Textbooks often say, all numbers are assumed to be to three digits of measurement. We call them significant digits. And of course, this is in meters per second. In science and physics in general, we're always looking at meters, kilograms, and seconds for all of our base units. And so we can see here the units for meters and the units there for seconds. And so that meters per second makes perfect sense. Okay. The P part of the process here is the paraphrase, and I just think of it as like therefore. You'd have a sentence, therefore the speed is 1.43 meters per second. Okay. This case is just evaluating. Solving process, just plug numbers in, do the division that it says, right? Sometimes students have to kind of point it out, be like, you're going to do this division, right? So put that as the divide symbol there and say, do it, right? And get the answer, right? Next harder case here, I'll go small, medium, and large, if you will, right? They're the last one's the weirder one. This one's not too bad, but let's do the same thing. We're going to say, okay, this is time. And this is speed, and we're asking for how far. So in other words, D, right? D is question mark. So here we go. We've got given. We know where's the order? T equals 7.5. And we have the V equals 2.6. That's in meters per second. And we have this D that I've pointed out as a required thing. I'm just switching colors. Makes it colorful. But as you're following through, you can see where I got things from in that. Again, analyzing, and you're like, hey, that's the same thing. Speed equals distance over that. Obviously, there's going to be other relationships. Just focusing on this one for this unit of the course that I'm making this video for. So here we go. We've got a speed goes in. Let's do the orange thing again. I liked it. So the T has to go in for T. So gonna have to go over in there, right? And then the V is going to have to go in for V. So right there, right? Not the top and the bottom on the right this time, of course. And go where they belong. So we're going to have the 2.6 in there. We're going to have the D waiting to see what happens. Some people get messed up with that too. What do I put for D? I don't know D. D was a variable. That's why it's there. And then the T was 7.5, right? So now we're not just dividing the 2.6 and the 7.5 this time. We have to look and see that that is, of course, a divide by 7.5, right? Hopefully you recognize that. And we want to get rid of it. We want to get what D is and not have that anymore. We want just D. We don't want D divided by 7.5. We want D distance. So what do we do to get rid of a divide by 7.5? We multiply, right? I feel like I should make this a little longer, or we kind of, I don't want it to be part of the process. Be like, just point out that that thing is this divide by 7.5, right? I'll leave it like that, good enough. But yeah, we're going to undo this, right? So we're going to undo with a multiply by 7.5. So that's why we're doing this. Multiply by 7.5, multiply by 7.5. Like that, I guess. So we have a 7.5 multiplied out. What happens when you do 7.5 divided by 7.5? That's really just all but 1, right? So that's why they cancel out. So you're left with 1D right there, right? This is 1D. So one of them. That should be pretty obvious when you look at it that way. So 7.5 times 2.6, 7.5 times 2.6 gives us 19.5. 19.5. And because we are meters and seconds and so on here, it's just going to be meters. Okay. If you want to look at the units, you could look at how the 7.5 is seconds, and do this purple maybe. This is a seconds, and then the 2.6 was meters per second. And so again, you've got seconds divided by seconds canceling out. You got your meters in the end. It's this little unit analysis, not always required, of course, but should make sense. Therefore, the distance is at 19.5 meters. That's how far Susan would go. Okay, so that's your first solving version. And it left them as like case A, 2A and 2B, because they're both solving, right? Just this is the trickier solving one. So let's go through. We've got a 200, which is clearly a distance, and an 8, which is a speed. So given D equals 200 meters, V equals 8 meters per second. And by the way, of course, we're using V for speed. No one in the right mind wants to use S as a variable because it's much like fives, especially with my rating. So V in this course is speed, and then later on, V with a bar is going to be a velocity. So V with bars, velocity. So you'll see that later in the course. That's just so you have a direction. So if you're wondering about speed being V, that's just common notation and physics stuff. We're asking for how long it will take. That is a time. So T equals question mark. Again, analyzing here, this is just, tried and true method. Later on, it'll be a different equation. Prompts you to look and pick the right one. Right? Seems kind of like obvious when you do this kind of question over and over again, but good to have that as your practice, your method. Again, putting numbers where they belong. The 200. Grab my orange marker better here. And the 200 needs to go in for D. The V needs to go in as 8. And so we're going to have 8 equals a 200 over a T. Right? So same kind of thing here. Like, looking at this thing, I have to think, okay, I want to get T all by itself. Eventually I want either T equals an answer or T equals an answer either way. Right? So we're just trying to figure that out. We don't want 1 divided by T, right? This isn't over T, this is a divide by T. So we don't want that instead, right? So let's point out this is a divide by T. We don't want it. We don't want that. We want a regular T. So what do? We undo it, right? Undo by multiplying by T. So multiplying by T, multiplying by T, right? That is going to make a T divided by T is just a 1. It kind of goes away. 200 divided by 1 is still just 200. So on this side, we have just 200. And then this side, we're going to have that 8T. Math people like to say 8T rather than T8. Right? T times 8. Clearly, it's the same thing. No big deal. Now, this is where you do another, what's going on here, right? So that is a multiply by 8. What do we do to get rid of it? We divide by 8. Right? So let's go undo with, or by, whatever, dividing by 8. 8. Check the numbers here, right? So notice how my T ended up on the left, but that's where it's left after that work. So we get rid of those things and get an answer here. So the 200 divided by 8 is a pretty easy number, but I mean, you don't need to stress out about numbers as you go through. It's going to be your 25, right? So 25 seconds. Again, we could analyze the units if we wanted to, but therefore it would take 25 seconds to travel that far. Okay, so there's your 3 versions of working with that basic equation, and you're just memorizing the one equation. You're used to using the one equation. You just have methods, and you just use algebra skills as they show up in front of you, as the need for them shows up in front of you, right? If instead you tried to memorize the 3 different versions, your brain just runs out of room to memorize stuff after a while, right? So just use math skills to help yourself be able to tackle anything. So this is where I'm just going to mention the memorization techniques that you'll probably hear and see, and I'd like you to commit to avoiding them. So these memorization techniques, if you see them in a flashy YouTube video, maybe flashier than mine, it might be tempting to use them as a way to get an answer in this particular case. But please recognize that the math skills that I'm showing are usable in any type of equation, right? Whereas these little tricks are limited to a very specific, simple case. So it's a pretty dead-end way of learning how to do something. It's just not going to work in future pieces, right? Which is a bummer. So one technique that you may have heard already or seen is to cross multiply. So you're like, okay, so cross multiply. Say I wanted to get D as an answer, right? I want to get the D value. Well, I could. I'm using air quotes here, but you're not seeing me. But I mean, this is a V over 1 and a D over T, right? So if you cross multiply, you bring the 1 up here and the T up there, and so you end up with D equals the time times the velocity of TV, right? So if these were both numbers, yeah, you calculate out that works, right? It's not terrible, it works. It's just not useful in a lot of other cases. Even a lot of cases with very similar forms. It's kind of silly to cross multiply, right? End up with the 3 up here and the 2 here, and you end up with 3x equals, 3x equals 2. And then you still have to get rid of that multiply by 3, so you still have to divide by 3, which you put it up there and now you're getting rid of it. It seems kind of redundant, right? So we end up with this x equals, once that's gone, we end up with x equals 2 over 3. Well, instead, I could have just said this x over 2 equals 1 over 3 stuff. All we needed to do is get rid of that divide by 2, right? So get rid of that divide by 2 by multiplying by 2, right? And that gives us this answer directly, one step only. So it boggles my mind that people say cross multiply so much. Just algebra rules, man. That's all you need. And really a pet peeve of mine, because it really obliterates any math thinking whatsoever, is the dreaded triangle. It's loved by students that don't know math skills, but those students, of course, eventually either duck out and don't do this kind of stuff anymore, or they have to learn algebra skills eventually, right? So I'm not even going to show how to use a triangle. I don't want to encourage it. I will just show one more thing. If you have more complicated equations, please don't stress out about what this equation is, right? It's an equation that is true. It makes sense. It's your final speed. So that's what V2 is squared equals your initial speed squared plus twice, like 2 times your acceleration times the distance you travel or your displacement, right? So it's a true equation. So if you're working with this equation and you're going to put some numbers into this, right? So we've got V2 is 10, so it's like 10 squared. V1 is given as 2, so it's 2 squared. And the acceleration is given as 4. And we want to know this d value, or delta d, we call it the triangle d, okay? You want to know that value. Okay, so that's the orange, the orange stuff here, where V2 was this one, and so on. I'll just leave it at that. So to solve for delta d, can we cross multiply? No, definitely not. Not relevant at all. Is there a triangle version of this? No, definitely not. Can we use some algebra skills to get this? Computer to catch up here. We use some algebra skills to get this and be like, yeah, yes, you can. Right? So I'll show you. It's not bad. Right? So let's take this number version that we've got, everything plugged in, and we're just going to do some math. So anything that's there just waiting to do, go ahead and do it, right? So like do the square, right? So you're going to get 100, and you're going to get 4, the square of the 2, 2 times 2 is 4. You're going to have the 2 times the 4 is the 8, and we just did bits and pieces here, right? And then your algebra skills have to kick in here where you want to get delta d all by itself. So there's a 4 you got to get rid of, and there's an 8 you got to get rid of. And so if you take away the 4 from both sides, right, that's still true, just like I showed earlier. You can add something to both sides, and you can subtract something to both sides. Each side just going to be a little, 4 less than it was, but they're still going to be the same as each other. So you end up with a 96 equals the 8 delta d. And then finally, and if I was doing the same stuff as earlier in the video, I would have pointed out that that is an add of 4. Like someone put a 4 right? Someone added a 4 there. And so you subtract from both sides. If it was a -4, you'd be like, oh, that's a subtractive 4. So we're just add it to both sides, right? And then along that same line here, that's a multiply by 8. So we're going to divide by 8. So divide by 8. And we do, again, fairly easy numbers here, but 96 divided by the 8 gives us a 12, right? So we get the 12 meters. Okay, so you can see that would, just algebra solving steps from grades 7, 8, 9 kind of thing. Give you the skills needed to work on any upper level science and physics and math you need to work with. So no memorization needed. Weird little tricks. Okay. I was going to show too, like if you plugged in the 12, say we knew the 12, maybe we knew the 12 and we wanted to know the velocity. So maybe we wanted to have the 12 and we wanted to know this one. What would we do? Well, then you'd have numbers like this. You'd have the 10 squared equals the v1 squared. We don't know it anymore. Pretending we weren't given that one originally. We're given the acceleration of 4 and we're given the displacement of 12. The nice thing about doing this, we know we should get an answer of 2, right? So what would we do? Well, there's a 10 squared waiting to be done there. There's a 2 times 4 times 12. So again, these numbers, but 2 times 4 times 12, right, gives me 96. So v squared plus 96. And then you'd say, oh, well, there's a 96 there that I got to get rid of, right? So I'm going to subtract the 96 from both sides. You get the number here of 4. So 4 equals v1 squared. And then this is where that root comes in, right? If you do the root of both sides, so technically in math it's plus or minus. If you do that, right? Because a positive number or a negative number squared gives a positive answer. So you have v1 equals technically plus or minus 2. And you can tell the plus 2 is the one we started with. And there's definitely some meaning to that minus case in a lot of cases. We're not going to worry about it here. But it's coming up in future stuff if you go on in this, in physics and life in general. Cool. All right, so that is it for working with equations using algebra skills. Thanks for watching. Like and subscribe, please. The more we can share this to people and students around everywhere, the more help everybody gets. And that's my goal. Thanks. Talk to you later.